So how do we name this molecule? Well, we start with the longest carbon chain. So there are 7 carbons in my longest carbon chain. So I would call this heptane. And I number it to give the substituent the lowest number possible. So in this example, it doesn't really matter if I start from the left or from the right. In both examples, you would end up with a 4 for your substituent there. Now, this substituent looks different from ones we've seen before. There are 3 carbons in it, but those carbons are not in a straight chain alkyl group. So if I look at it, right, there are 3 carbons, but they're not going in a straight chain. They're branching here. So this is kind of weird. How do we name this substituent? Well, down here I have the same substituent, and I'm going to draw this little zigzag line to indicate that that substituent is coming off of some straight chain alkane. And when you're naming a complex substituent like this, you actually use the same rules that you would use for a straight chain alkane. So you first identify the longest carbon chain, which in this case is only 2 carbons, right? So that would be an ethyl group coming off of my carbon chain. So I'm going to go ahead and name that as an ethyl group. I'm going to go ahead and number it, right, to give my branching group there the lowest number possible. So I go 1 and 2. So what is my substituent coming off of my ethyl group? Well, that's a methyl group coming off of carbon 1. So I name it as 1-methyl ethyl. Okay, so now that complex substituent is named as 1-methyl ethyl. So I could go ahead and put that into my name. So coming off of carbon 4, I have 1-methyl ethyl, and I'm going to put that in parentheses, and all of that is coming off of carbon 4 for my molecule. So for 1-methyl ethyl heptane would be the IUPAC, would be an acceptable IUPAC way of naming that molecule. So if you're naming your complex substituent as 1-methyl ethyl, that's the official IUPAC way. But there are also common names for these complex substituents. So the common name for 1-methyl ethyl is isopropyl. So isopropyl is the common name. And isopropyl is used so frequently that it's perfectly acceptable to use isopropyl for the name of this molecule as well. So you could have said, oh, this is for isopropyl heptane, and you would have been absolutely correct. So that's yet another IUPAC name. So iso means same, and it probably comes from the fact that you have these two methyl groups giving you this Y shape that are the same. So that's one complex substituent, one that has 3 carbons on it. Let's look at a bunch of complex substituents that have a total of 4 carbons on them. So all of these guys have a total of 4 carbons, and let's do that same trick with the zigzag line so we can ignore the rest of the molecule and just think about them as being alkyl groups. So how do I name these? The same steps. You find your longest carbon chain. So for this one, the longest carbon chain would be 3. It's an alkyl group, so it's propyl. And when you number it, all right, this would get a 1, this would get a 2, and this would get a 3. So you have a methyl group coming off of carbon 1 here. So it would be 1-methyl propyl as the name of that complex substituent. The common name for that is sec-butyl. So butyl, because there are a total of 4 carbons. Let's do the next one. So 1, 2, 3 again. So when I number it 1, 2, 3, I can see that it would be propyl once again. So I go ahead and write propyl here. And what is coming off of that group, right? Well, I have a methyl group coming off of carbon 2 this time. So it would be 2-methyl propyl. So 2-methyl propyl for this complex substituent. The common name for this is isobutyl. So butyl, again, because there are 4 total carbons in this complex substituent. Iso, because once again you have these 2 methyl groups, so they're like the same, so you get that Y formation. So that's isobutyl. The next one, longest carbon chain. There are 2 carbons in my longest carbon chain, so that would be ethyl. And when I number my longest carbon chain, I can see that I have 2 methyl groups, and each of those methyl groups is coming off of carbon 1. So I would say this would be 1,1-dimethyl ethyl.
So 1,1-dimethylethyl would be the IUPAC name for this complex substituent. You will also see tert-butyl. So tert-butyl is probably used even more frequently. So tert-butyl, again butyl because there are a total of 4 carbons here. So those are the 3 possibilities for a complex substituent with a total of 4 carbons. Let's look at just a few of the possibilities for complex substituents that have 5 carbons. There are actually much more than this, but these are the ones that are most commonly used. So let's just focus on these 2. So once again, we'll draw our zigzag line to represent the fact that this is actually connected to some straight chain alkane. And once again, we find our longest carbon chain, 1, 2, 3, 4. So that would be butyl. And when I number that carbon chain, 1, 2, 3, 4, I can see that I have a methyl group coming off of carbon 3. So it would be 3-methyl-butyl for the IUPAC name. And this is also called isopentyl. So you could say isopentyl, since there are 5 carbons now. And iso, because again, you have this methyl group and this methyl group looking like a Y. They're like the same thing. Or I've seen this called isoamyl before. So isoamyl or isopentyl are acceptable IUPAC names as well. What about this one on the right? Longest carbon chain, 1, 2, 3. So that would be propyl. And numbering it, 1, 2, 3, immediately it is obvious that you have 2 methyl groups coming off of carbon 2. So it would be 2,2-dimethylpropyl, otherwise known as neopentyl, since once again you have 5 carbons for these. So again, there are many more, and we'll stop with those. And so that gives you an idea about how to approach naming complex substituents. And of course, when you name complex substituents, you have to use them when you're naming straight chain or cycloalkane molecules. So let's look at a cycloalkane molecule, and let's see how to name this guy. Well, I have 4 carbons in my ring, and I have 4 carbons in this group. So tie goes to the cycloalkane. So remember from the last video, if you have an equal number of carbons in your ring as with your chain, you're going to name it as an alkyl cycloalkane. The cycloalkane wins the tie. So there are 4 carbons, so this would be cyclobutane. So let's go ahead and write cyclobutane here. And once you've determined that you're going to name it as a cycloalkane, then you have to look at this complex substituent and say, okay, well that's 1, 2, 3. So that would be propyl. And then when you number that complex substituent, 1, 2, 3, obviously there is a methyl group coming off of carbon 1. So you would write 1-methylpropyl, so 1-methylpropyl. And if you wanted to, you could identify that 1-methylpropyl as coming off of carbon 1 of your cyclobutane. So you could put this in parentheses and write 1-methylpropyl cyclobutane, or you could just leave the 1 off and say 1-methylpropyl cyclobutane because again it is implied. What is the common name for this complex substituent? So 1-methylpropyl, we go back up here and we find 1-methylpropyl was also called sec-butyl. Okay, so we could have also named this molecule sec-butyl cyclobutane. So let's go ahead and write that. So sec-butyl cyclobutane is a perfectly acceptable IUPAC name as well. So it just depends. Do you want to do it the official IUPAC way, or do you want to memorize some of these common names? Let's do one more thing in this video. Let's classify carbons. Okay, so we're going to do something called classification of carbons. This is a topic that comes up over and over again throughout an organic chemistry course. So the earlier you learn this concept, the better off you are. So classification of carbons. So let's say I have carbon connected to 3 hydrogens, and then I also have it connected to 1 other carbon in some R group. I want to know how to classify this carbon. So this carbon is connected to 1 other carbon, so therefore we say it is primary. So that is a primary carbon right there.
Let's take off one of the hydrogens and let's put on another R group. So I'll make it R prime to distinguish it from the first R group. So this time, if I wanted to know the classification of this carbon, it's connected to two other carbons. So it is said to be secondary. So it is a secondary carbon like that. And I'm going to once again take off one of the hydrogens. So I'll make it an R double prime group. And now, if I wanted to classify my central carbon, now this is connected to 1, 2, 3 other carbons, so it is said to be tertiary. So that is a tertiary carbon like that. And finally, I have one more example, of course. I take off the last hydrogens. Now I have R, R prime, R double prime, and R triple prime. So what is the classification of this carbon now? Connected to 4 other carbons, so it is said to be quaternary. So that is a quaternary carbon right here. So quaternary. All right. So if I'm trying to think about where some of these common names come from, right? I can see, oh well, right here I have, if carbon's bonded to 2 other carbons, well, that would be secondary, right? So SEC for my prefix. So let's go back up here and let's see if we can find those examples, right? So here I have this carbon bonded to 2 other carbons. So this carbon was said to be secondary. So I think that's where this comes from. I've never seen that explained in a textbook or anywhere, but it just makes sense. So it's ignoring the fact that this carbon is actually attached to a ring. It's saying this carbon on my complex substituent is bonded to 2 other carbons, so it is secondary on that complex substituent. What about tertiary, right? So carbon bonded to 3 other carbons is said to be tertiary. So if I go back up here again, I can say, well, that would make sense because if I look at this carbon, it's bonded to 3 other carbons, right? So I could say that is a tertiary carbon. And once again, I'm ignoring the fact that this carbon is actually bonded to another carbon on the ring. Okay, so if you just look at the complex substituent, that carbon is said to be tertiary, which is I think is where the name comes from. Let's do one more example of assigning classification of carbons to this molecule. So let's look at this carbon right here. This carbon is bonded to 1 other carbon and 3 hydrogens. So this carbon is said to be primary. This carbon right here is bonded to 2 other carbons, so it is said to be secondary. This carbon right here is bonded to 3 other carbons, so it is tertiary. This carbon is bonded to 1 other carbon, so it is primary. This carbon is bonded to 3 other carbons, so it is tertiary. And all of the carbons on the ring right here are bonded to 2 other carbons, so they are all said to be secondary. So that's a very important skill to develop, classifying your carbons. Again, this will come up in future videos with different functional groups.